Back. Today we're going to be looking at the last topic in this unit, and we're going to be looking at problem solving. Now, whenever it comes to creating your own equations, there can be a little bit of anxiety or a little bit of nervousness around it, but if you can break it down into the basic steps and look for all of the keywords, then it becomes a much easier process. So as you're trying to create your word problems and create your systems of equations, there's some key steps that you're going to follow. And the first one is to define your variables. So as you read through your word problem, there's often going to be a question at the end and some key information throughout that's going to tell you what the unknowns are. And so because in this unit we're looking at a system of equations, you're often going to have two unknowns. And so you're going to define those variables. It might be an unknown cost, it might be an unknown value, but you're going to set it up as x equals this amount and y equals this amount. And it's important that you're clear with your variables. If you just say x represents books, that doesn't tell me whether we're talking about the number of books or the cost per book. So it's important that when you're defining your variables, you're clear on specifically what you're meaning, not just books or cats or cell phones. Once you have your variables defined, then you need to set up a system of equations. Now, for every unknown, you need one equation. So if you have two unknowns, you need two equations. If you have three unknowns, you have three equations. In this unit, we're primarily focusing on just two equations. Once you have your system of equations, then we just go with everything that we've done throughout this unit. You're going to solve algebraically, and so that means you're going to be solving using substitution or elimination. You can still solve by graphing or verify by graphing, but for these word problems, I'm asking that you solve them algebraically. And then the last step is to answer the question. Now, sometimes we're setting up our system of equations, but we're actually only being asked for one of the unknowns. We have to set up both equations to figure out both unknowns, but the answer might only be one of those, or we might have to take the information we've got and go one step further with it. Also important when you're answering your question that you remember units. So throughout this video, I'm just going to go through 6 different examples. Throughout, I'm going to use both methods, one substitution, one elimination. You may have a preferred method, and you can use that method for everything. I find that some questions lend themselves better to substitution or elimination, and sometimes you could go either way. So use whichever method you're more comfortable with, but I'm going to try to go through both methods throughout the video so that you can see how both could be used. All right, let's get into it. First example here is a geometry style question. So if you're given a geometry question, often what you want to do is draw a picture. So the labeling or the defining of your variables can be done by drawing a picture. So the question says, a rectangular pool has a length that exceeds the width by 2 meters. The perimeter of the pool is 44 meters. Find the dimensions of the pool. Often when we're doing geometry questions, we're required to remember some formulas from before. And in this case, we're going to have to remember perimeter. Sometimes we have to remember area. But the first thing we're going to do is draw a picture. And once we have our picture, then we can label our variables. Now we know that we have length here and we have width here. And we're told that the length exceeds the width by 2 meters. So exceeds the width by 2 meters. We don't usually use the word exceeds a lot in math, but you can often put this into your own words. So if the length exceeds the width by 2 meters, that means the width is 2 more than the length. So we can rewrite the length as W plus 2. So we have length and we have width, but we also know that length is width plus 2. So as we go to set up our equation here, we can write that length, or L equals length. Now we have that already in our diagram here, so you could write it off to the side here. Length equals L and width equals W. And then we can set up our formula. So we have length equaling width plus 2. So that's our first equation, width plus 2. And I'm going to label these equations as I go. So length is width plus 2. And let's read further in. It says the perimeter of the pool is 44 meters. So the perimeter is 44 meters. And if we're talking about perimeter, then we're using that formula, P equals 2L plus 2W. So again, this is the formula used in junior high, and you're going to have to remember it. So setting up that formula, our perimeter is 44. So we have 44 equals 2L plus 2W. Now, at this point, we've defined our variables, we've set up our equations. Our next step is to solve. And this is where we're going to decide whether we use substitution or elimination. Well, when I look at these two questions, I can see that I already have L being set equal to W plus 2. So for me, the most logical step to use will be substitution. So I'm going to substitute this into there. So I'm going to solve using substitution. All right, so I have that L equals W plus 2, so I'm going to rewrite my equation. 44 equals 2 times L, which is W plus 2, plus 2W. All right, multiplying through, I have 44 equals 2W plus 4 plus 2W. Simplifying, that gives me 44 equals 2W plus 2W is 4W plus 4. I'm going to subtract 4 from both sides. And that gives me 40 equals 4W. I'm going to divide by 4. And we have W equals 10. Now, I'm not worried about units at this point because I'm just solving the question, but we've got W equals 10. Now, once I have that, I'm going to sub back into my other equation. Now, my other equation was L equals W plus 2. So L equals W plus 2. I'm going to do my substitution. So L equals 10 plus 2, meaning L equals 12. Now, the last step, I've got all of my numbers. Certainly, you can go back and double check. I often will graph to double check my answers. But once I have my two amounts, I'm just going to go back and do a quick check to see if they match what I have here. So L is W plus 2. So I check if I were to plug those in, width plus 2, 10 plus 2 is length. That exceeds by 2 meters. And if I were to plug the rest in here, 2 times L, so 2 times 12, plus 2 times 10 equals 44. So just doing that quick check tells me that, yeah, I'm probably on the right track. My last step then is to answer the question. And the question said, find the dimensions of the pool. Well, the dimensions of the pool are 10 by 12. So my length is 12 meters. Again, units are important. And my width is 10 meters. So I'm not worried about units until the very end, but it's important that you have a clear visual of your answer. All right, so it's a good idea when you're doing these to also keep as organized as possible. So I've labeled my variables off to the side, I've set up my equations, I've got a space where I'm doing my solving, and then I've clearly identified where my final answers are. So as we go through, we're going to follow the same process. Each type of example that I show you is going to be a different type of example that you can see that uses systems of equations. So this is one example. This is with geometry. Anything with geometry, often your first step is to draw a diagram. All right, let's look at the next question. So the next type of question that you can see is a sharing problem. And this is where you're going to have one amount that's being broken into different amounts or broken up into parts. And so let's read through the question here. So it says a person invested $2,500, part at 8% and part at 10%. There's the sharing piece. We're putting part of the amount into one section and part of the amount into another section. We're also dealing with percentages here, so that's going to add a little bit of an extra piece as well. So again, I'll read through this. A person invested $2,500, part at 8% and part at 10%. After 1 year, the total interest earned was $240. How much money or how much was invested at each rate? So as we read through this here, we know that we've invested $2,500. We know that amount of money has been broken into two parts. And after a year, we have a total interest earned. And that total interest earned is $240. So again, there's a requirement here that you have some previous knowledge about how to calculate percentages, how to break things up into parts. But I'm going to talk you through this, and then as you see other examples, you can use this to refer to. So our first step is to always define our variables. And so as we look here, we have two amounts. Our unknowns are what those two amounts are. And our question can guide us there. It says how much was invested at each rate. So our unknowns is how much money was invested at each rate. Now you can use any variable that you want. I'm going to choose A and B. X and Y works perfectly fine as well. And so A will represent the amount invested at 8%. Now it's important that I'm clear on that. If I just wrote A equals 8%, that doesn't tell me enough. So A is the amount invested at 8%, and B is the amount invested at 10%. We have this tendency to want to just shorthand everything, and that's important. That's okay to do, but you still have to make sure that you're clear in what everything is. So we have A being the amount invested at 8% and B being the amount invested at 10%. So when we're looking at these parts, part A plus part B equals $2,500. Those two amounts total up to $2,500. So my first equation is going to be A plus B equals $2,500. Now the second one is a little trickier because it requires us to look at percentages. So it says after 1 year, the total interest earned was $240. Well, if I want to figure out the amount of interest earned on an amount, I'm going to figure out the percentage of that object. And if you remember of in math means multiply. So for example, if I wanted to figure out what, if I was doing GST, for example, and I wanted to figure out what 5% of $100 is, I would go 0.05 times 100. In this case, I want to figure out what 8% of an amount is. So 8% of that amount would be 8% times that amount. Or 10% of a number would be 0.10, so 0.10 times that amount. So when I want to figure out my total interest earned, I'm going to take the percent of the amount and add it to the percent of the other amount. So my formula will look like this. I'm going to have 0.08A plus 0.10B equals $240. So labeling that, if that would help here, as I label this here, this is going to represent the interest earned on part A. And this is going to represent the interest earned on part B. And this $240 represents our total interest earned. So if we're doing the percentage of a number, remember that we're multiplying. All right, so we have our two formulas here. We've got A plus B equals 2,500. We've got 0.08A plus 0.10B equals 2,500. And all right, so let's do some solving here. Now, I chose again to use substitution because this one is quite easy to manipulate and turn into substitution. So I chose to rearrange and solve for B. You could just as easily rearrange and solve for A. So rearranging this, I'm going to have B equals 2,500 minus A. Again, you could write that as negative A plus 2,500. So subbing the first equation into the second equation, I'm going to have 0.08A plus 0.1, and instead of B, I'm going to write 2,500 minus A equals 240. Simplifying, I've got 0.08A. I'm going to have to multiply this part out. So 0.1 multiplying through, that gives me 0.1 times 2,500 is 250 minus 0.1A equals 240. Combining those, I've got 0.08 minus 0.1, so I'm combining my like terms. That gives me negative 0.02A plus 250 equals 240. Now, you could have moved over the 250 as well if you're comfortable with skipping steps, but I'm just going through them all in detail here. And so I would subtract 250 from both sides. And that gives me negative 0.02A equals 240 minus 250 is negative 10. Dividing by negative 0.02 on both sides. gives me A equals 500. Now I know what A is. I need to go back to my original question to see what B is. So I had A plus B equals 2,500. So A plus B equals 2,500. I'm going to sub in what I know. So 500 plus B equals 2,500. Sometimes these are fairly easy to do in your head, but it's still important that you show your work. We're subtracting 500 from both sides. And then B equals 2,500 minus 500 is 2,000. So again, we've done all this work. It's important that we go back and refresh our memories and see what we were being asked for. The question says, how much was invested in each rate? Well, double check your questions. 2,000 plus 500 adds up to 2,500. And if I go 0.08 times 500 plus 0.1 times 2,000, I'll get 240. So I know I've done this correctly. So my final answer would be, you can write it as variables, or you can write that we invested $500 at 8% and $2,000 at 10%. So our final answer would be that we invested $500 at 8% and $2,000 at 10%. If it's helpful, again, you can also label your variables. This is A and this is B. All right, so we're going to look at a couple more problems that are also kind of like that sharing type method, but they're just different contexts. So here we're looking at values. So we're told that Bill paid $1,760 for a used car. He used $100 bills and $20 bills to pay for it. There were 28 bills in all. How many of each type did he have? So breaking this down, he paid $1,760 for a used car. And he did that using $100 bills and $20 bills. So those are our two parts. We don't know how many $100 bills and how many $20 bills he used, but we know that the combination made up $1,760. We also know that there were 28 bills in all. And the question is, how many of each type did he have? So our question is, how many $100 bills and how many $20 bills did we have? So we'll set up our variables first. So I'm going to use X for number of $100 bills. Now I'm quite picky when I look at word problems here. If you just wrote X as $100 bills and B or Y is $20 bills, I'm going to tell you I don't have enough information. I need to know what you mean about those $100 bills. So number of $100 bills is important. And then Y would be the number of $20 bills. Now, we have to set up our equation. And if you look in this question, we have some amounts that represent dollar amounts, and we have some numbers or variables or values that represent number amounts. And so if you can remember, when we're dealing with questions like this, money goes with money and numbers go with money. So money with money and numbers with numbers. And so we start off with our numbers here. We have 28 bills in all. Well, X represents the number of $100 bills and Y represents the number of $20 bills. So our first question, our first equation is going to be X plus Y is 28. So the number of $100 bills plus the number of $20 bills is 28. And the second step is to combine our values. So we have $100 bills, we don't know how many, and we have $20 bills, we don't know how many, and that's going to total to $1,760. Well, 100 times however many $100 bills I have will tell me the value of the $100 bills, plus 20 times Y. So 20 times however many $20 bills I have tells me the value of the 20s. Well, the value of the hundreds plus the value of the 20s is going to equal $1,760. So there's our two equations. Now our next step is to solve. And I'm going to solve this time using elimination. So I set up my equation, X plus Y equals 28. And 100X plus 20Y equals 1760. Now looking at this, substitution is just as easy to use. I'm just trying to expose you to the other method. So by all means, you could use this or solve this using substitution as well. All right, so solving using elimination, I'm going to multiply my first equation by 100 because I'm going to try to eliminate my x's. So multiplying by 100, that gives me 100x plus 100y equals 2,800. And my other equation was 100x plus 20y equals 1,760. And since my signs are the same, I'm going to be subtracting. So 100 minus 100, those disappear. I'm left with 0x. And then I have 100 minus 20 is 80y. And 2,800 minus 1,760 is 1,040. Dividing by 80, I have y equals 13. Now, going back up to my other equations here, because I use the elimination method, I can sub into either of these. To me, the first one looks a lot easier to sub into. So I have x plus y equals 28. X plus 13 equals 28. Simplifying here, we're going to subtract 13 from both sides. And we're left with x equals 15. Now again, it's always good to go back and double check. 13 plus 15 is 28. 100 times 15 plus 20 times 13 is 1,760. So I know I'm correct. All right, so there's my values. My final answer then, I'm going to have 15 $100 bills. And I'm going to have 13 $20 bills. At this point, because you've already identified your variables, you could also just write that x equals 15 and y equals 13, and that would be fine. Now, when I say that sometimes you have to be careful to answer the question, I could, instead of asking you how many of each type, I could ask you what was the value of the $100 bills. Well, then you would have to go one step further and say, well, 15 times 100 was $1,500. Or I could have said, what was the value of the $20 bills? And you could do the same type of thing. So it's important that you always read that final question, because sometimes finding the unknowns isn't the last step. All right, let's take a look at another example here. So this is very similar to our sharing and our value problems. And this time we're looking at theater tickets. So a movie theater charges $11 for an adult ticket and $8 for a child's ticket. So we have $11 for an adult ticket and $8 for a child's ticket. And we're told that 240 people attend. So assume or suppose that 240 people attend the movie and ticket sales total $2,370. And the question is, how many adults attended the movie? So while we're only being asked for adults, we still have two unknowns. We don't know how many children's tickets there were. We don't know how many adults tickets there were. So we're going to start off by defining our variables. And so we have adult tickets and child's tickets. So I'm going to use A and C. Often I'll set up my variables using letters that represent the problem. Sometimes that makes it easier in the context of the question to recognize which variable represents which amount. So A represents the adult tickets. But if I just say A represents adult tickets, that's not enough information. A represents the number of adult tickets. Because we could say that A represents the value of the adult tickets. Now, we already know the value, but A represents the number of adult tickets. You could have also said A represents the number of tickets at $11, which would work as well. And then C represents the number of child tickets. Or you could have said the number of tickets at $8. So once we have those, we're going to set up our equations. Now, going back to our last example, we try to keep the values with the values and the numbers with the numbers. Well, we know that there are $11 for an adult ticket and $8 for the child's ticket, so that's going to relate to the $2,370, and the 240 represents the number of, or the amount. So our first equation is usually the easiest one to set up here. A plus C, so the number of adult tickets plus the number of child tickets, is 240. Notice all of these represent number amounts. And then the number of adult tickets, the value of the adult tickets, well, we have $11 per adult ticket. So $11 times however many adult tickets there are, plus $8 times however many child tickets they are, gives us 2,370. So again, we have value. So the 11A represents the value of adult tickets, 8C represents the value of child tickets, and then we have our total value here. So we're going to go through and solve. This one here, I've chosen to use substitution. Again, elimination works very well as well. I'm going to set this up and solve for C. And the reason I'm rearranging for C is because in the end, I'm being asked for just the adult tickets. So I wouldn't have to necessarily do the entire question. So I'm going to rewrite this in terms of C so that my final solution ends up in terms of A. So C equals 240 minus A. So what I'm doing is creating a process so that my final answer will be A equals. All right, so using the substitution here, I have 11A plus 8 instead of C. I'm going to write 240 minus A equals 2,370. Multiplying this out, I'm going to multiply that 8 through. I have 11A plus 1,920 minus 8A equals 2,370. Simplifying, we've got to combine our like terms here. So we have 11A minus 8A is 3A. So 3A plus 1,920 equals 2,370. We're going to subtract 1,920 from both sides. And that gives us 3A equals 450. Dividing by 3 on both sides, we have A equals 150. Now, technically, there we're done. We know that there are 150 adult tickets, but because I want to go back and double check to make sure that all of my values work, I'm going to continue the question. So my original equation was A plus C equals 240. I'm going to plug in that A value, 140 plus C, so 140 plus C equals 240. Subtracting 150 from both sides, I have C equals 90. And I'm doing that just so that I can go and verify my answers. So 150 plus 90 is 240. 11 times 150 plus 8 times 90 is 2,370. So I know I'm correct. So my final answer was that there was 150 adult tickets, or 150 adults. I think it says how many adults attended. So 150 adults attended. All right, so again, you didn't have to figure out how many children attended, but by doing that, you have a way to double check your answers and make sure it fits with the problem. All right, we have a couple more examples here. The next type of question you can see are mystery number questions. And the most challenging part about these questions isn't so much setting up it is setting up the equations, but it's reading carefully for keywords. There's so many different ways I can ask you these questions. And the most challenging part is remembering those words from before: sum, difference, product, multiple, factor. All of those words are going to come into play when we're looking at mystery number problems. But the same methods apply. We're going to read through the problem, we're going to define our variables, set up our equations, and solve. So here the question says, find two numbers such that their sum divided by 4 is equal to 14. The greater number increased by 24 equals 3 times the smaller. So these ones you just want to break down. If you read it as a whole paragraph, it gets very overwhelming very quickly. But ultimately, we're looking for two numbers. So we're looking for two numbers. I'm going to label them X and Y. And we're told that their sum divided by 4 is equal to 14. Well, that's going to relate to the equation, but we're told the greater number increased by 24. So we know that one number is bigger than the other. So I'm going to label this one as my first number, and I'm going to decide that this is the bigger number because I need to know that for when I set up my equations. And the second number is going to be my smaller number. So then the second number will be my smaller number. If you're not told that one is greater than the other, then you don't need to worry about that. You can just say first number, second number. But because we're very clearly told that one is greater than the other, we have to include that information. All right, so we've got these two variables defined. And we're told that the first one, it says their sum divided by 4 is equal to 14. Well, sum is a key word. Sum means that we're going to add. So their sum, x plus y, divided by 4. Oops, let's try that again. X plus y. So their sum divided by 4 is, so is means equal. So sum means add, divided by 4. So divided by 4 is equal to 14. So there's our equation already. Their sum, so x plus y divided by 4 equals 14. Now I can rewrite that so it's in a linear equation, and it would be x plus y equals 56. Let's take the next question, or the next piece of information here. So it says the greater number increased by. Increased means adding. So the greater number, and we've already decided the greater number is x. The greater number increased by 24 equals 3 times the smaller amount. Well, 3 times means 3 times the smaller amount would be 3y. So the greater number, x, increased by 24 is, so equals 3 times the smaller. So when you're doing these types of questions, I find it very helpful to actually break down the word problem, highlight, color, fill in, rewrite over top, writing your words as symbols. All of that can help. So don't be afraid to get in there and mess up the paragraph and add your own information as needed. All right. So this particular question, again, I decided to use elimination. And so I have x plus y. I have x plus y equals 56. And x minus, I'm going to rewrite this one here, x minus 3y equals negative 24. So I'm rewriting it so that I can line it all up. So x minus 3y equals negative 24. Remember that when we switch sides, we switch signs. We're going to put brackets around this. And these are the same signs, so I'm going to subtract. So x minus x is 0, so those disappear. Y minus 3y becomes, y minus a negative 3y, so y plus 3 becomes 4y. And 56 minus a negative 24 becomes 80. So it's important that you pay attention to those double negatives. And so I have, dividing by 4 here, I have y equals 20. Now I'm going to go back to my original questions. I'm choosing to work with the first one there. I've got x plus y equals 56. I know that y is 20, so x plus 20 equals 56, and x equals 36. Again, you always want to go back and double check. So 20 plus 36 divided by 4 is 14, and 36 plus 24 equals 3 times 20. So my answers work. So I know that my numbers are 36 and 20. Now, you've probably seen some of those Mensa puzzles. Sometimes these questions are quite common when you're looking at Mensa problems, and really it's just breaking it down using a systems of equations. All right, continuing on, we've got one more example here. And I actually took this one out of your textbook, but we're looking at a rate problem. And so we're basically taking those rate equations that we wrote in one of our other units on linear equations, but now we're setting it up as a system of equations. So we're going to be looking for keywords like rate or slope or increased or decreased and so on. So let's read through the question here. It says that 2 hopper bottom grain bins are being emptied starting at the same time. The larger bin holds 45 meters cubed of grain and is emptied at a rate of 1 meter cubed per minute. Remember that rate often refers to slope. The smaller bin stores 30 meters cubed of grain and is emptied at a rate of 0.5 meters cubed. And if it's being emptied, that means the volume is decreasing. And it says determine when the bins will contain the same amount of grain. So we know one of our unknowns for sure is when. The other thing that we don't know is we don't know how much grain is included. So we're actually using the formula y equals mx plus b, but we're going to be setting up our variables based on what we're looking for. So our first one is volume. We don't know what the volume is. So V is going to stand for volume of the grain bins. And that volume is in meters cubed. and T is going to represent time. So setting up our equations here, our first equation will be the volume of the first bin. And so I'm going to start with the larger bin here. So V is going to be 45. We start with 45 meters cubed, and it's decreasing at a rate of 1 meter cubed per minute. So we would have 1 meter cubed per minute. If we're decreasing, it's going to be 45 minus 1t. Now, that's basically taking our y equals mx plus b formula and rewriting it. So we're rewriting it as y equals b minus mx because the mx happens to be negative. So it's like writing this, negative mx plus b, because it's a negative slope, because it's decreasing. All right, so while it looks different than y equals mx plus b, it's just y equals mx plus b in a different format, just rearranged. All right, so looking at our last formula, our second formula here, the smaller bin stores 30 meters of grain and is being emptied at a rate of 0.5 meters cubed per minute. So the volume of our second grain bin starts at 30, and then it's being decreased by 0.5 meters cubed. Notice I'm not putting any units in the equations because we have enough numbers to deal with here. Now, this is a question I'm going to solve using substitution. I have two values for V. V equals 45 minus 1t, and V equals 30 minus 0.5t. Well, these are starting at the same time, and we're being asked when our amounts will be equal. So when will this amount equal this amount? So I'm going to set these two amounts equal to each other. So basically, I'm taking this 45 minus t, and I'm subbing it in for V. So I'm taking this value of V and subbing it in for this value. So using substitution, I have 45 minus 1t equals 30 minus 0.5t. Rearranging, now we have variables on both sides of the equation. So ultimately, my goal is to get all of my variables together. So I'm going to add 1t. I'm going to add 1t to both sides. And at the same time, I'm going to subtract 30 from both sides. So you can do this in 2 steps or do it in 1 step, whichever you're more comfortable with. All right, so we have 45 minus 30 is 15. And negative 0.5 plus 1 gives me 0.5. 0.5t. I'm going to divide by 0.5. And that gives me t equals 30. It doesn't matter now which equation I sub into, but I'm going to, actually at this point I would be done, but if I wanted to go through and check my answer, I could plug that in. So I'm going to use the first one here, 45 minus 1t. Again, this is a step I'm using just to verify my answers. 45 minus 1 times 30. V would be 45 minus 30 is 15. So my volume is 15, my time is 30. And so the question is just saying, when will the bins contain the same amount? Well, they will contain the same amount when t equals 15 minutes. So you could just write t equals 15 minutes, and that's fine. But I just want to be clear on the answer here. So they'll contain the same amount when t equals 15 minutes. Now, sometimes you'll be asked how much is contained when, or how much volume, how much grain would be there when they contain the same amount. Well, then we could go 1 step further and say 15, there would be 15 meters cubed. So t equals 15 minutes, and V is 15 meters cubed. But the answer to this specific question, determine when the bins will contain the same amount of grain, is just that it will contain the same amount of grain when t equals 15 minutes. All right, so those are 6 different examples. You'll notice that 3 of them are all very similar. They all kind of relate to that parts being broken up into shares, but some involve percentages. If you can just go back to those basics of labeling your variable, setting up your equation, solving, and then rereading that last question to see what you're being asked for, you should be well on your way to doing word problems. All right, thanks a lot, guys. Have a great day.